Hello students, welcome to this lecture, and in this lecture we are going to learn few questions and the application of 3-dimensional geometry based on CBSE pattern. So, let us see the first question, which is of 1 mark. It says find the direction cosines of the sides of the triangle whose vertices are given to us. So, if vertices are given and we have to find the direction cosine of the sides, so how will we proceed? We know that when we subtract the position vector of one vertex with the position vector of another vertex, we will get one of the sides of the triangle. So, if we subtract this one from this one, we will get a vector which is along the side of the line joining these two vertices. So, this is a triangle and this is a vertex A, this is a vertex A and this is a vertex B. So, this is a vertex B. Now, if we want to find the vector AB, we will say that the vector AB is equal to position vector of B is minus I cap plus j cap plus 2k cap, whereas position vector of A is 3 I cap 5 j cap minus 4k cap. So, we will subtract. So, what will happen? Minus 4 I cap is the x component, then minus 4 j cap is the y component, and then plus 6 k cap is the z component. If we want the unit vector along the direction of this side, we will get 16 plus 16 32 plus 36, that will be 68. So, we can say that minus 4 upon root over 68 I cap minus 4 upon root over 68 j cap plus 6 upon root over 68 k cap. This is the unit vector, which means the direction cosines along this line AB is minus 4 by root over 68 comma minus 4 by root over 68 comma plus 6 by root over 68. So, this is the direction cosine which is along one of the sides, and we have to find for all the sides. So, we will proceed similarly for other sides also. So, let us proceed for the side BC. This is C now. So, if we want to find the vector BC, we will again subtract the position vector of B from the position vector of C. So, we will get minus 4 I cap and then we will get minus 6 j cap and then we will get minus 4 k cap. So, minus 4 I cap and then we are getting minus 6 j cap and then we are getting minus 4 k cap. Its modulus is also same, 16 plus 36 plus 16 under root. So, we will get the direction cosine as minus 4 by root over 68 comma minus 6 by root over 68 comma minus 4 by root over 68. So, this is the other side. When we talk about the third side CA, that particular vector C and A. So, which vertex we are taking? C, this vertex as C. So, CA is actually position vector of A minus position vector of C, which will give you 8 I cap and then 10 j cap and then minus 2 k cap. So, let us write it here, 8 I cap plus 10 j cap and then minus 2 k cap. What will be its modulus? 64 plus 100 is 164 plus 4 is 168. So, the direction cosine of this side is 8 by root over 168 comma 10 by root over 168 and comma minus 2 by root over 168. So, this is how we find the direction cosines of the three sides of the triangle whose vertices are given to us. So, it is a lengthy question, but not too difficult. So, it is a 1 mark question. Next question shows that says that, let us first erase all these writings here. So, the first question says that show that the line through the points 1 minus 1 2 3 4 minus 2 is perpendicular to the line through the point 0 3 2 and 3 5 6. So, again if a line joining 2 points is perpendicular to a line which is joining another 2 points, then that means the vector along this and the vector along this are perpendicular, which means the dot product of these two vectors should be 0, that is the scalar product, as the angle between them is 90. So, cos 90 will be 0. So, if we want to find the vector along this, we will just subtract these 2 points, and the vector along this will be, let us suppose A vector is equal to 2 I cap, and then y component is plus 5 j cap, and then we have minus 4 k cap. What about B vector? B vector we see 3 I cap when we subtract this point from this point, plus 2 j cap and plus 4 k cap. Now let us take the dot product of A and B. So I component will multiply with I component, rest different components will become 0. So 2 I cap dot 3 I cap is 6, 5 j cap dot 2 j cap is 10, and minus 4 k cap plus 4 k cap is minus 16. So this will come out to be 0, which means since AB are non-zero vectors, so the angle between them is 90 degrees. So these are perpendicular vectors. So this is how we will solve this question. For the next question, third one, which is of 2 marks, find the vector and the Cartesian equations of the line that passes through the points. These 2 points are given to us. So we have to directly apply the formula here. Since we know that the line passing through 2 points in vector form can be given as r is equal to the position vector of any one point we will take. So let us take the position vector of this point plus lambda times difference of the position vectors of these 2 points. That means the vector along that line actually comes from the difference of the position vectors of these 2 points. So 3 minus 3 will be 0 I cap, minus 2 plus 2 will be 0 j cap, and 6 minus minus 5 will be 11 k cap. So we get the vector along the line as this. So this is the vector equation of the line. If we want to write the Cartesian formula, what we will say, x minus 3, and can you see the vector along x component is actually 0. So we say 0, y plus 2, we are simply doing x minus x1, y minus y1 and z minus z1 in the numerator. In the denominator, the direction ratios of the vector. So direction ratios are 0, 0 and 11. So how can we express it in a more simplified form? We will say that if this is equal to lambda, that means x is equal to 3, x minus 3 by 0 is equal to lambda, means x equal to 3, and y is equal to minus 2. Next, z can take any value depending upon the varying value of lambda. So what type of line does this represent? This represents that it is at a distance 3 units from the origin along the x axis and minus 2 units from the origin along the y axis. So if we consider that we have x, y, z axis like this, so which type of line this is? This is a line which is actually parallel to xy, oxy plane. This is parallel to oxy plane, and it is parallel in such a way that it is at a distance of 3 units from origin along the x axis and minus 2 units this direction along the y axis. So this actually tells us that this line is actually parallel to XOY, this particular plane. Let us come to the next question. Next question says, and that question is also of 2 marks, fourth question. Find the equation of the plane with intercept 3 on the y axis and parallel to ZOX plane. So here it is saying you have to find the equation of that plane with intercept 3 on the y axis and parallel to ZOX plane. So first we should go mathematically, that if the plane is having intercept 3 on the y axis and the parallel to ZOX plane, which means the perpendicular to the plane is actually perpendicular to ZOX plane, because the plane is parallel to ZOX plane, which means the perpendicular to the plane, that is the normal vector, should be perpendicular to ZOX plane, of course. So if it is perpendicular to ZOX plane, then in that case let us consider that this is the figure, this is your x axis, this is origin, this is y axis, and this is z axis. This is the ZOX plane. Actually, if you see in 3-dimension figure, this is the ZOX plane. So, in this plane, the given plane is actually parallel to it. So, its normal is perpendicular to this plane. So, we can say that it is perpendicular, the normal is perpendicular to the z axis as well as the x axis. So, the angle which the normal makes with the z axis is actually 90 degree, which we call gamma as the direction angle, and beta and alpha, which is the angle which it makes with the x axis, also 90 degree, and the angle which it makes with the y axis, that is beta, is equal to 0 degree. So, it is along the y axis. So, what will happen? Cos gamma will be 0, cos alpha will be 0, but cos beta will be 1. So, we will write Ax plus By plus Cz is equal to D as the equation of the plane. First note this down, students, then we will just see. So, students, after noting this down, you can understand that this angle is actually alpha 90 degree, beta 0 degree, and gamma 90 degree. So, cos alpha will be 0, cos gamma will be 0, and cos beta will be 1. So, the direction ratios are 0, 0, 1, or we say direction cosines are 0, 1, 0, sorry, alpha, beta, gamma, 0, 1, 0. So, these are actually the direction ratios of the normal to the required plane. So, this A will be 0 and this C will be 0, and since cos beta equal to 1, so coefficient of y will be present. So, we will say that By is equal to D should be the form of the plane, which can be written as y is equal to D by B. Now, since we know the intercept which this plane makes with the y axis is actually 3 units. So, this value should be equal to 3 units. So, y is equal to 3 is the equation of the plane which is parallel to ZOX plane, and it is at a 3 units from the ZOX plane. Okay, students. So, this is the equation. Now, let us move on to the 5th question, and this question is of 4 marks. Find the shortest distance between the lines, and there are 2 lines given. So, first we have to observe that which type of lines are these 2. So, if we talk about the first line, it is having direction ratio 1, minus 1 and 1. If we talk about the second line, it is having direction ratio 2, minus 1 and 2. So, the direction ratios are not same or not similar, because 1 by 2 and minus 1 by minus 1 is not equal, and of course not equal to 1 by 2. So, these 2 lines are not parallel, which we want to first decide that whether these 2 lines are parallel or not, because if these 2 lines are parallel, then we will apply the formula for distance between parallel lines. But if these 2 are not parallel, we will apply formula for distance between skew lines. So, the distance between skew lines is, as you remember, mod of A2 minus A1 dot B1 cross B2, and let us put this mod here, upon mod of B1 cross B2. Now, what are these terms? A1, A2, B1, B2. So, if you observe, this is A1, this is A2, this is B1, this is B2. B1, B2 are the direction of the line, and A1, A2 are the points through which these 2 lines are passing. So, if we want to find this numerator, we will draw a determinant and take the mod of that determinant. The first row will be A2 minus A1 components. So, A2 minus A1, 2 minus 1 is 1, so we write it here, minus 1 minus 2 is minus 3, and minus 1 minus 1 is minus 2. Now, the component of B1 vector, which is 1 minus 1, 1, and the component of B2 vector, which is 2 minus 1 and 2. So, this is your A1 vector, this is your A2 vector, this is your B1 vector, and this is your B2 vector. So, you should understand from where we are taking these terms. B1 cross B2 is actually again putting the first row as ijk and another 2 row are same as in the numerator, that is B1 and B2 and modulus of that. So let us calculate. If we will calculate this determinant, 1 minus 2 plus 1, that is minus 1. So we first write minus 1. This will become plus 3 and we will have 2 minus 2 0. So this will multiplied with 0 and then we have minus 2, this is minus 1 plus 2 which is 1. So minus 2 divided by I component will have minus 2 and then it will plus 1. So minus I cap. For j cap it is 2 minus 2 0 and for k cap it is minus 1 plus 2, that is 1. So when we take the modulus in the numerator, we will get minus 1 0 minus 2 as minus 3 and mod of that is 3. In the denominator, root over 1 square plus 1 square. So that is root over 2. So this is the distance between the given two lines and we are getting a value which is not 0, which means that these two lines are not intersecting and these two lines are skew. If in case these two lines were intersecting, we would have got the value 0 here. Now let us move on to the 6th question, which is also of 4 marks. It says, find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector 3i cap plus 5j cap minus 6k cap. So if you remember vector equation of a plane, in the first form, it needs a unit vector perpendicular to the plane and distance of that plane from the origin. So distance of the plane from the origin is given, which is 7 units. This is actually d. And what else is given? Normal to the vector, but it is not a unit vector. But we can form the unit vector. Magnitude we know, 9 plus 25 plus 36. What will be that? 9 plus 25 will be 34 and plus 36 will be 70. So root over 70 is the magnitude. So we can directly write that r dot n cap, which is a unit vector perpendicular to the plane, and that is actually 3 by root 70, as its magnitude is root 70, I cap plus 5 by root 70 j cap minus 6 by root 70 k cap is equal to d, which is actually the distance from the origin of this plane, and that is 7 units. So you can write it like this and simplify it further, that it is r dot 3i cap plus 5j cap minus 6k cap and take this root 70 on the right hand side. So it will be 7 root 70. So this is the equation of the plane which we want. So we just need to understand the formula. We don't need to remember the formula, we have to understand the formula, then we can apply it in any case. Let us come to the 7th question now, which is again of 4 marks. Find the equation of the plane through the line of intersection of the planes this and this, which is perpendicular to the plane this. Okay. So first we can write the family of plane which may pass through the intersection of these two planes. So what is the family of plane? Pi 1 plus lambda pi 2 equal to 0. So this will become x plus 2 lambda x. So we can write 1 plus 2 lambda x, y plus 3 lambda y. So 1 plus 3 lambda y, y is common of course, and z plus 4 lambda z. So 1 plus 4 lambda z is equal to 1 plus 5 lambda. So this is family of planes which is passing through the line of intersection of the given two planes. Now the particular plane which we want from this family is actually perpendicular to this plane. So if two planes are perpendicular, do you remember the angle between planes? Yes, cos theta, that is actually angle between the normal vectors to the plane. So here that theta is equal to 90 degree. That means that the angle between these two vectors and these two planes is 90 and cos 90 is 0, which means if we take the direction ratio of this normal to the plane, which is 1 plus 2 lambda, 1 plus 3 lambda, 1 plus 4 lambda, and the direction ratio of this plane, which is 1 minus 1 1, and take the dot product, that should come out to be 0. So 1 plus 2 lambda into 1 is actually 1 plus 2 lambda. 1 plus 3 lambda into minus 1 is minus 1 minus 3 lambda, and 1 into 1 plus 4 lambda is 1 plus 4 lambda. That is coming out to be 0, dot product. So we can say 1 will cancel here, 2 lambda minus 3 lambda is minus lambda, plus 4 lambda is 3 lambda, is equal to minus 1 in our right side, lambda is equal to minus 1 by 3. Now after knowing the value of lambda, which is actually equal to minus 1 by 3, can we find the equation of the required plane? We have to just substitute lambda equal to minus 1 by 3 here. So 1 minus 2 by 3 will be 1 by 3 lambda. What we are doing, lambda is equal to minus 1 by 3. I am substituting in this equation. Here when we will do, it will become 0. Here when we will do, this will become 1 minus 4 by 3, that is minus z by 3. This is x here, as we have substituted lambda, is equal to 1 minus 5 by 3, that is minus 2 by 3. So finally it will become x minus z is equal to minus 2, which is the required equation of the plane. And this plane is actually passing through the line of intersection of given two planes and perpendicular to the third plane which is given. Next question is of 6 marks, question number 8. Find the equation of the plane passing through the point, and point is given to us, and perpendicular to each of the planes, this and this. These two planes are also given to us. So they are saying that the plane is actually perpendicular to each of these two planes. Later on we will use the concept and the given condition that it is passing through the point, this one. So first we have to visualize it. If a plane is perpendicular to this plane, that means as well as this plane, can we say that if we take the normal to this plane and normal to this plane and do the cross product of this, we will get a line which is along the intersection of these two planes? So just let me draw a figure. This is a plane, this is another plane at some angle. I am saying that if I take a normal to this plane n1 and another normal to this plane n2, and if we do the cross product of n1 and n2, what do we get? We will get a vector which is along the intersection of these two planes, this vector. Just try to understand, these two planes are there and this is a normal vector, this is a normal vector. I am taking the cross product of this normal vector with this normal vector. So this thumb will be along the line of intersection of these two planes here. So first what we have come to the conclusion is that if these two planes are intersecting at some line, then we can find that line, okay, and its direction. Now we have to find the equation of the plane perpendicular to each of the planes. So if this plane is perpendicular to this plane as well as this plane, it is actually perpendicular to the line which is the intersection of these two planes. Okay, just this third plane is perpendicular to these two planes. That means the line which is through the intersection of these two planes, this plane is perpendicular to that line, which means that the required plane will have a normal along this line. So we have come to a final conclusion that if we say that the plane which is required has a normal vector, that normal vector is nothing else but the cross product of the normals of these two vectors, right students? So what is the cross product? Let us see. I, j, k and 1, 2, 3 first normal, 3, 3, 1 second normal. So this will become 2 minus 9 minus 7 I cap, and for j cap what we will do, 1 minus 9 minus 8, so it will become plus 8 j cap, and for k cap 3 minus 6, so minus 3 k cap. So this is n1 cross n2. Now we write the equation as minus 7x plus 8y minus 3z is equal to d. So, these A, B, C are actually direction ratios of the normal to the plane, which is -7, 8 and -3. Now, we have to find this D. So, we will use the concept that this is passing through -1, 3, 2. We substitute it here. So, when we substitute x as -1, this will become 7 and this y as 3. So, this will become 24 and this z as 2 -6 is equal to capital D. So, what we will get? Capital D is equal to 24 minus 6 is 18 plus 7 is 25. So, we can say the equation is -7x plus 8y minus 3z is equal to 25. So, this is the equation of the required plane. So, we have to understand, and it is very important to visualize the different figures and the lines and the planes which are given in the question. Then only we will able to approach the question. Let us move to the 9th question. Find the distance of the point is given from the point of intersection of the line this and the plane this. So, this line is intersecting this plane at a particular point. So, what you have to do is find the distance of this point from that point of intersection. So, what we will do? We will first find the point of intersection of this line with this plane. So, how do we do that? We assume that this r vector, which is giving a point on the line, is intersecting this plane at a particular point x1 comma y1 comma z1. So, any point on this line can be given by the help of this equation as x1 is equal to 2 plus 3 lambda, that is the x component, -1 plus 4 lambda is the y component, and this lambda actually varies and we get the different points. 2 plus 2 lambda is equal to z1. So, we assume that any point on this line can be given like these coordinates, but we want specifically the point where this line is intersecting the plane. So, these coordinates must satisfy the equation of this plane because they also lie on the plane, that is the point of intersection of the line with the plane. So, we substitute x1 y1 z1 here, and when we substitute it in place of r as x1 I cap plus y1 j cap plus z1 k cap and do the dot product with this, we will get 2 plus 3 lambda into 1 minus 1 plus 4 lambda, because here it is -1, plus 1 into 2 plus 2 lambda is equal to 5. So, from here we will get a value of lambda. See what is the value. So, this 2 plus 1 5, and this 5 cancels. 2 lambda plus minus 4 lambda is -2 lambda plus 3 lambda is lambda. So, lambda comes out to be 0. So, for lambda equal to 0 we get a point which is equal to 2 minus 1 and 2 for lambda equal to 0. And for these particular points we find that this line is intersecting this plane. So, if we have to now find the distance of this point from this point, what we will do? We will apply the distance formula and we will say root over x2 minus x1 whole square. So, 2 minus 1 whole square plus y2 minus y1 whole square minus 1 minus 5 whole square plus 2 minus 10 whole square. So, this is what we will do here. So, x2 minus x1 whole square, y2 minus y1 whole square and z2 minus z1 whole square. This will come out to be root over 9, this will come out to be 16, this will come out to be 144. So, this is root over 169, which is equal to 13. So, this is the required value, or we say the distance between the 2 points. One point is given in the question and another point we have found out, as it is the intersection of the plane with the line, and the plane and the line are given to us. Now let us come to the last question, which is also of 6 marks. Prove that if a plane has the intercepts A, B, C and is at a distance of p units from the origin, then this is the relation between A, B, C and P. This you have to show. So if we say that the intercept of a plane has intercepts A, B, C, then the intercept form of the plane is x by A plus y by B plus z by C is equal to 1. This is the intercept form of the plane. Now the distance of this plane from origin is given as p units. So what is the formula for distance of a plane from any point? We will substitute the point here in place of x, y, z, which is here 0, 0, 0, and write 0 plus 0 plus 0, and this will come here minus 1 and modulus of this by root over sum of the square of the coefficients of the 3 variables. So 1 by a square plus 1 by b square plus 1 by c square. And if you see the question, this d is already given as p. This is the p unit, distance from the origin. So we can say p is equal to, here it will become 1 by root over 1 by a square plus 1 by b square plus 1 by c square. So we can say that the relation between p and ABC is, after we will multiply it here, divide it here and square both the sides, we will get 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. So this is the relation which we had to prove, and we have proved it. We need to know two concepts. One is the distance of a plane from a point, another is intercept form of plane. So that is all for the questions for 3-dimension geometry. Thank you, students.